Alrighty, now let's move on to lesson 2, understanding subtraction of positive and negative integers. So what happens when you subtract a positive and negative number? Well, let's look at this situation they have listed down below. In the previous lesson, you learned that 5 plus negative 3 on the number line looks like this. You start at 5, and then you move left in the negative direction 3 units to represent adding negative 3. You end up at 2. Add 5 here, and then we went, because this was a negative integer, to the left of 5, 3 spots, which left us as at the spot 2. Now let's look at this another way. Think about this. How is subtracting integers like adding integers? Think about the subtraction problem 5 minus 3. I have 5 fingers, and then I take 3 away. I have 2 fingers left, which means that my answer would be 2. Now, because addition and subtractions are inverse operations, because the inverse of subtraction is addition, and vice versa, you can write this equation as an addition equation. You can also say that 3 plus this 2 equals 5. What I normally do is ask myself, well, what number do I add to 3 to get to 5? You can also do it on a number line to represent it. You can start at 5, and then you could say, well, I know that some 3 things that I have to have. What do I have left? These 2 things. You start at 5 and you move left 3. When you look at the number line at the top of the page, it represents 5 plus negative 3 right here. And the number line above, which represents 5 minus 3 here, you should notice that they're exactly the same thing, which is what I just said. And this shows an important relationship between the addition and subtraction. It shows that any subtraction problem can be written as an addition problem, which is very, very important. So take a moment to study this, pause your screen, so that way you can really memorize this portion right here. This thing says basically if you have 5 minus 3, you can change it to an addition sign, which was what we did in our notes, and then change this to the inverse of positive 3, which would be negative 3. Very good. So say it with me. The inverse of 3 is negative 3. So that means that every subtraction problem can be written as an addition problem. So if you know how to add positive and negative numbers, you basically know how to subtract them. And here are some of the examples. You have 4 things and you get rid of 4, you have goose egg. You have nothing. Nothingness. And on the number line, it represents like this. 4, and then you take away 4. Poof, 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 poof. Took away 4. Now, the same thing here. 4. I'm adding quantity negative 4. Poof, 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 poof. Now, what about this next one here? What about 1 minus 3? Well, I'd have to start at 1, and then I would have to still go to the left of that 1 3 spaces. So I'd go 1, 2, 3, which puts me right here at negative 2. And the same thing can be said if I said 1 plus the quantity negative 3, which would still give me negative 2. Uno, dos, which puts me right here. Now think a moment to reflect on this, what we just learned. Why can you write a subtraction problem as an addition problem? How can you write a subtraction problem as an addition problem? You can write a subtraction problem as an addition problem because subtraction is related to addition. They are opposite operations, or they're opposite of one another. They're inverses. So to write a subtraction problem as an addition problem, you add the opposite of the second number to the first number. So it's just adding the opposite. All subtraction is adding the opposite. The opposite of the second number to the first number. So let's say it with me. This is very important. Subtraction is just adding the opposite of the second number to the first number. That's very important. Let's move on to the next page. And this is what we were doing in last class. And this is what I want you guys to have completed by October 9th. Is this piece of paper here. If we could get that done in our small groups, that would be great. But I'm also going to be doing it online, so that way you have the information up to date, and you really don't have to do anything but just follow along and listen and understand why things are happening, and write down questions that you have while I'm doing this. So that way you can say, well, Mr. Sprouse, at minute yada yada yada, you did this. Why in the world did you do that, son? But you can ask me questions like that, and it'll be fun. I'll be able to answer them. We'll be able to have a good time. I'll get you on the right track, and you're going to meet that goal of increasing your iReady level grade by 1. So let's look at this first one. This first problem states that Adam buys 9 gift cards. Then he gives away 6 of them because Adam's a good guy. How many does he have left? And what it wants us to do here is it wants us to write a subtraction problem to represent the situation. Then write a subtraction problem as an addition problem. And then model it on the number line. And use the number line to answer the question. So I know that he had 9 to begin with. He got rid of 6. He got rid of 6 of them. So he got rid of 6 of the things. That's one way. We wrote it as a subtraction problem. That's good. We met one of the parameters. Now that's one way to do it. I'm going to put it in a box so that way I know that's the first part. Now I need to write this as an addition problem. Now remember from the notes that we took that we can always represent a subtraction problem as an addition problem. But you have to do 2 parts in 1 step. First part was to change the subtraction to an addition operation. So I just changed that. Second step said change the second add-in. Second add-in was positive 6 here, so I need to make it negative 6. Right? And now I need to show you exactly how this is done on a number line. So for the sake of consistency, I'm going to be using this one, which is the first number of lines, or first things we modeled in the class. I'm going to take that, and I know my first add-in is 9, so I'm going to mark 9 right here on the number line. I know that is a length of 9 units, 1 for cards in this thing. This example was represented by cards. Gift cards, that is. Maybe there were gift cards to Piggly Wiggly or McDonald's or Roadhouse. What's your favorite restaurant? Let me know in the comments below. And then I need to take away 6 things, or I need to move to the left of this point 6 spaces. So 1, 2, 3, 4, 5, 6. Which means our answer is 3. And these are all equal to one another. Now we did number 2 in class. And so for this one, we need to think about number 4. It says Rob is trying to read for 30 minutes each Saturday. He only reads 20 minutes last Saturday. Let's underline that. He read 20 minutes last Saturday. He represented the amount of time he was short of the total 30 minutes as negative 10 minutes. This Saturday, he wants to make up. It means he wants to add the difference between the number of minutes he usually reads on Saturday and the number of minutes he was short last Saturday. How many minutes will Rob need to read this Saturday? So this Saturday, he wants to make up for the difference between the number of minutes he usually reads on Saturday and the number of minutes he was short last Saturday. How many minutes will Rob need? We know that Rob, on the first Saturday, he wanted to get 30 minutes, but he really didn't get that. So we need to add or take away that negative quantity of 10. We want to show that he also made it as